Welcome everyone, thanks for joining today's demo. We will discuss about zero packet loss for your CNF running in OpenShift on OpenStack. My name is Emilia Maki and I work as a developer in the Shift on Stack team, and I'm with Ziv Greenberg, our senior software quality engineer focusing on NFV and Shift on Stack. On today's agenda, we will have an introduction about Shift on Stack. We will also discuss the OpenStack requirements, and then we will go over the deployment of the OpenShift cluster and how you can run your workload with zero packet loss. Why Shift on Stack? Red Hat OpenStack has a large footprint in NFV space for a long time. Also, we know that Red Hat OpenShift is now a leader in the platform as a service industry. We have observed that the network functions have been transitioning from virtual machines to containers. And if you are interested by this, I put a link at the bottom of the slide and you can have a look. Shift on Stack helps with that transition. Collocation of the virtual network function and the cloud native network function help to share the same infrastructure resources such as compute, network, and storage. The OpenStack NAV features are well integrated into OpenShift. For example, in the cluster API provider for OpenStack, named as Capo, and also the SRIOV network operator. Let's discuss about the OpenStack requirements before you deploy OpenShift and your application. All the tests that we have been doing are with the Neutron ML2 OVN plugin in the OpenStack cloud, which has been the default for some time now in Red Hat OpenStack. And we also had to deploy the Neutron SRIOV agents, so the agent can manage the virtual functions on your device. The supported network devices on the compute nodes are documented on an article that is linked into this slide, and you can check whether your hardware is supported or not on the version of RHEL that you're running. The compute nodes have to be configured with the huge pages and the CPUs that will be used for Nova, either dedicated or shared CPUs. The Nova flavors have to be created for the CNF workers, and we will see that later in the demo that you can specify NUMA and CPU policy, but also memory page size, etc. And finally, the compute nodes have to be plugged onto the provider networks for DPDK or SRIOV or OVS hardware offload. Okay, so let's jump on the demo. So this part of the demo will show how to prepare the OpenShift cluster, and the second part of the demo from Ziv will demonstrate how you can achieve zero packet loss with your workload. So first of all, we need to install the OpenShift cluster, and keep in mind that we support both IPI and UPI. In this demo, we will use IPI. You can deploy 3 masters and 3 workers directly, but keep in mind that the 3 workers will not be ready for the CNF workloads. And typically, the CNF workers are deployed on day 2, which is what we will do today. So if we look at the cluster right now, we have 3 machines for the control plane and 3 nodes. So now on day 2, let's prepare the workers for running the CNF. The first step is to deploy the performance profile. The performance profile depends on your hardware. For example, how many CPUs do you have, how much RAM do you have, etc. You can have as many profiles as hardware configurations. So the performance profile that we use will be applied to all the worker nodes. You can see that we have a list of kernel args that we want to have, and then the CPU isolated and reserved, And finally, I wanted to show you the huge pages. So we have 4 huge pages of 1 gig each. Let's create this performance profile. The performance profile was created, and we can see the right configuration that was applied. The next step is to deploy the CNF worker nodes. In the demo, we will use IPI methods using the machine sets. Typically, you will want to create a machine set per worker node, so you can fine-tune the configuration of the workers. For example, if a specific worker has a flavor with a NUMA node or CPU policy or a specific number of huge pages, then you will want to use that flavor for this machine set. In the machine set, we also configure the network attachment. The network attachment defines the networks and the ports that will be plugged in on the worker nodes. The networks are typically provider networks for connecting on the DPDK, SRIOV, or OVS hardware offload kind of networks. Here you can see the machine set that we created for one worker. To create a machine set, you can use the default one that was generated when you deployed that cluster, and then you can change the name of the machine set and tune the provider spec directly. So we have the flavor name, which is named M1X large NAV. Let's have a look at the flavor. So the flavor for that worker has properties for NAV, which are CPU policy set to dedicated. We have huge pages set to large, and we have a PCI NUMA affinity policy set to preferred. Of course, it all depends of your hardware and how do you want to configure the worker nodes. Here we have the port attachment. On this worker, we would have one port connected to the SRIOV network. Um, the network ID is the Neutron network ID, and you also have the subnet ID to provide. It's very important to set the VNIC type here for SRIOV, which is direct, which means that we will expose a VF directly on the worker. We disable port security, and we disable trunk. The machine set was created, and now let's scale it to 1. So 1 worker will be created. So if we look at the machines, one should have been provisioned. It's provisioning. We can look for the SRIOV port and make sure that it has the right attributes. So now we should see the VNIC type set to direct, which is the case. We should see the server being created. Okay, so the server was created and attached to the SRIOV network. And yeah, so the machine is provisioned, but the nodes is not created yet. It will take a few minutes. So let's have a look in a few. Okay, so back to it. The worker should be deployed now and ready. So we can disable scheduling on the masters. And now we have 3 masters for the control plane and 1 worker. The worker has to be labeled to be network SRIB capable. Okay, so now we have the worker uh, ready to be used for the CNF application. Let's just have a look at it and see, confirm that we have all we need on the machine. Let's take a look at the CMD line, and we can see the CPU isolation and the huge pages. And now let's have a look at the huge pages, and we can see that we have 4 of them of 1 gig.
Hello everyone, I'm Ziv, a QA member from ShiftStack team responsible for testing NFV features. Following Emilian's demo, I will demonstrate how zero packet loss can be achieved with SRV and DPDK workloads. Today's demo agenda is as follows. Review of the performance lab, installation and configuration of the SRV network operator, performance test run for SRV scenario, and finally performance test run for DPDK scenario. So let's begin by reviewing our performance lab. In this diagram, you can see 2 bare metal OpenStack computes. We have compute 0 on the left, which is our OpenShift control plane, with masters and management nodes. Additionally, we have T-Rex, our traffic generator, that will help us to generate telco traffic and test our cluster. On the right, we have compute 1, our data plane, which has 2 workers, worker 0 with SRV capable NIC, and worker 1 with DPDK capable NIC. Okay, now that we're familiar with the lab, we can move on to the terminal. The first step will be to install and configure the SRV network operator, which will allow us to use the pre-created SRV and DPDK OpenStack networks. Let's take a look at the manifest for the SRV network operator and install it. It should take about a minute or two. Now that the operator has been installed, we can review and create the network node policies. Here we can see that we are using NetFilter to attach an OpenStack network that has at least one VF. Okay, so after installing the SRV network operator and creating the SRV and DPDK networks, it's time to move on to the performance test. First, let's quickly review the manifest for the SRV pod. Below you can see that I have allocated 3 isolated CPUs and 1 GB of huge pages to the pod. The image we're using already has DPDK libraries installed. And since the SRV ports are already in the user space, we can just start the testPMD application after the pod creation. Let's create this pod now. Our pod is up and running. Let's discover the MAC addresses of the attached VF ports. We will need them for the next step. Okay, we are finally ready to start the binary search script, which will generate traffic from T-Rex toward the DOT pod. And at the end of this test, it will give us the possible MPPS, million packets per second, that this setup can get with 0 packet loss. I'm starting this test at 12 Mbps, but in this tuned system it should reach at least 13.7 Mbps. Alright, we see that the flow has been established and that the stream for port 0 is reaching port 1 at a speed of 12 Mbps, as well as the port 1 sending packets to port 0 at the same speed. And so far it looks good and stable. Let's also check the testpmd application on the DOT pod to ensure there are no packets error. It looks absolutely fine. There are no errors on either the transmit or the receive side. Okay, so it will take around 10 to 50 minutes to complete this test. I'll pause here and return with the results. We are back with the SRV perf results. So we got 13.9 Mbps per port, a total of 27.8 Mbps. Almost a new line for the 10 GB NIC. Okay, so let's start the TPDK DOT pod now and test it as well. Here we can see I'm starting the perf test with much lower Mbps, simply because this is what DPDK can achieve with only one PMD. As with previous test, I'll pause here and return with the perf results. Hello again, let's review the DPDK perf results. We got 1.8 Mbps and total of 3.6 Mbps. To summarize it, as long as both platforms are properly tuned and configured, ShiftStack CNF will be able to achieve the same performance results as OpenStack bare metal. And with that, we can finish this demo. I'd like to thank you for your time. Goodbye.